We're going to take the terms of a sequence and we're going to sum them up. But since the sequence is infinite, this becomes now an infinite sum. So you've never done this before. This means we're going to add a sub 1 plus a sub 2 plus a sub 3 plus a sub n plus, and it just keeps going. And even though you may be very good with your calculator, you're never going to sum one of these things up that way, because there's no such thing as an infinite amount of time to do an infinite one homework problem. One homework problem you'd never get finished.
Didn't take a limit.
So what we do is we define what's called the sequence of partial sums. Sequence of partial sums, which is formed by the first partial sum is just the first term. The second partial sum is the sum of the first two terms. The third partial sum is the sum of the first three. The nth partial sum is the sum of the first n terms. And what we do is we look at this sequence. And if that sequence converges, then we say that the series converges. So you're going to make a new sequence out of this. On your calculators, you have a key that says SUM and a parentheses, and you can put some sequence, and you can sum terms up that way, but that still won't answer whether the series converges or not. You need more than that. So let's do one, so you have a little example. So suppose I said, find the first 4 partial sums, and we're going to do it for the sum of 1 over 2 to the n. The first partial sum is just the first term. Okay, have at it. Find the S2, S3, and S4. Lovely. S sub 1 is, because it's A sub 1, but now you need S sub 2, which is going to be A sub 1 plus A. Yeah, find the first 4 of them. Oh, you haven't added them yet. Fine. Now add them. Go ahead and add up the individual sums. The first 4. I think you meant 16, maybe. Oh, is that a 15?
Yeah.
Oh, okay. That's fine with me. Oh, go ahead and add them up. Those are the correct numbers. So the first one was 1/2, and then the second one would be 1/2 plus 1/4.
3/4.
And that's 2/4 plus 1/4, so 3/4. And the third partial sum is 1/2 plus 1/4 plus 1/8. So that's 2/8 and 4/8 is 6/8 and plus 1. So that should have been 7/8. And the fourth one was 1/2 plus 1/4 plus 1/8 plus a, let's see, 2 to the 4th is 16. So that's 2 and 4, 6 and 8 is 14 and 1. How about 15/16? How'd you do? Okay, so I realize that this is what I'm trying to sum up, but what I ask about then is this sequence.
What's the limit? Is it and what's the limit until it approaches infinity?
Well, I can't take that limit until I can find a little expression for this. Yeah.
Is it n over n plus 1?
No. No, the bottom's not bad. The bottom's 2 to the n.
N squared minus 1 is the top?
N squared
No.
minus 1.
No.
2 squared minus 1 is 1. No, 2 squared, yeah, I don't think so. This is n is 2. 2 squared would be 4 minus 1 is 3, yeah.
2n minus 4.
This would be,
2n was...
how about 2 to the n? Yeah, how about 2 to the n minus 1?
Yeah, that's what I was thinking.
How about that? That'll work out. Because the bottom's 1 less, the top is 1 less than the bottom in each of these cases. So now what I do is I say, okay, what's the limit as n approaches infinity of this thing? And I remind you again of, I was going to do old Calc 1. Let's divide by the highest power kind of down in the bottom. If we divide through by 2 to the n, that'll be a 1. And now it's easy. Well, maybe it's easy.
1 minus 0.
1.
So 1.
So we say that this series converges and it has a sum of 1. So we would actually write that equals 1.